Hi everyone. In this video, I would like to present the solutions of problems in question bank on module 1, and from part A. The problems are a type of problem solving and critical thinking, and it is in part A, first video. So I'd like to solve the problems on, I think module 1 means it is differential equations. So in module 1 and module 2, we are going to solve the differential equations. In module 3, the partial differential equations. In module 4 and 5, the vector calculus. So now we are going to solve the problems on module 1, and which are the differential equations of first order and first degree. And this is in part A, this is the first video. And solve the differential equation. See the first problem. Solve the differential equation x square y dx minus of x cube plus y cube of dy. So clearly it is a first order and first degree differential equation, and moreover this equation can be written as dy by dx is equal to x square y by x cube plus y cube. So this equation is a homogeneous linear differential equation. This is a homogeneous. Already we have seen in the regular videos. This is a homogeneous differential equation because the right hand side it is a homogeneous function of degree 0. In numerator the degree is 3. In the denominator also 2 plus 1, the degree is 3 in the numerator. In the denominator also the degree is 3. This is having degree 3 and this term also having degree 3. So on cancelling degree 3, it is a homogeneous function of degree 0. Or mathematically you can say that if you consider f of kx ky, if it is k power 0 into f of xy, then it is a homogeneous function of degree 0. So you can here you can observe that if you write a x for kx and y for ky, this equation k square x square into ky by k cube x cube plus k cube y cube. So in numerator it is k cube x square y. In the denominator, on taking out k cube outside, it is x cube plus y cube. So on cancelling out k power 0, this is k power 0 into f of xy. That means what? It is a homogeneous function of degree 0. If it is a homogeneous function of degree 0, then we can solve it by reducing to variable separable form. So how to reduce it? We know that the suitable substitution we take here, y is equal to vx. We take y is equal to vx. Then dy by dx is equal to v plus x into dv by dx. And call this as equation number 2. Now on substituting 2 in equation 1, then 1 gives, then what implies 1? 1 gives dy by dx can be replaced by v plus x into dv by dx. On the left hand side it is x square, y is replaced by vx, by x cube plus v cube into x cube. Or I can write it as x cube into v by, on taking out x cube in the denominator, x cube into 1 plus v cube. So this and this will get cancelled. So what we will get is v plus x dv by dx is equal to v by 1 plus v cube. So on writing v this side, what we will get, x dv by dx is equal to v by 1 plus v cube minus v. So what is LCM here? LCM is 1 plus v cube on the right hand side. In the numerator it is v minus 1 plus v cube. V minus v into 1 plus v cube by v cube. So that we will get, in the next slide I will show that x dv by dx is equal to, what is on the right hand side? the right hand side is v by 1 plus v cube, v by 1 plus v cube minus v. Or what I can write on the left hand side, 1 plus v cube. In the numerator I have v minus v power 4. On the left hand side the same as it is, x into dv by dx. Or v cancel, it is minus v power 4 by 1 plus v cube. On the left hand side x into dv by dx. Now clearly this equation can be separate with respect to the variables. So we can write v variables all on dv side and x variables on dv side, dx side. So on rearranging, on separating the variables, 1 plus v cube by v power 4 dv is equal to minus dx by x. So 1 plus v cube by v power 4 on going this side, dv is equal to minus dx by dx. So this is clearly v variables on dv side and x variables on dx side on integrating both sides. On integrating, integral first term 1 by v power 4 dv. Second one v cube by v power 4, that is 1 by v dv, and it is integral minus dx by x plus c. Or what I can write here, v power minus 4 integration, integral v power minus 4 dv, v power minus 4 plus 1 by minus 4 plus 1, or minus 1 by 3v cube, that is the integration, minus 1 by 3v cube. Here plus 1 by v integration, log v is equal to minus log x plus c. But what is v? But v is equal to y by x, or y is equal to vx. So I'm substituting minus x cube by 3y cube plus log y by x. On writing minus log x left hand side, plus log x is equal to c. Or this is minus x cube plus 3 by 3y cube plus log m plus log n, log mn. So this is log y only, this is equal to c, which is the required solution. So the given equation is in homogeneous differential equation form. We can solve it by using y is equal to vx, so that the entire equation changes into the variable separable form. So v variables write dv side and x variables on dx side. Then on taking integration both sides, you will get the required solution. So that is the first problem in part A. And see the another problem. Solve dy by dx plus 2y is equal to e power x plus x, where the given condition y of 0 is equal to 1. What is y of 0 is equal to 1 means? When x is 0, y is equal to 1. When x is 0, y is equal to 1. That is the condition given. So this is a differential equation of first order in linear form. You can observe that directly. So what is the linear differential equation? A differential equation is of the form dy by dx plus py is equal to q, where p, q are functions of x. Then it's a solution. Then solution is y into e power integral p dx is equal to integral q into e power integral p dx plus c. This is the solution. If the given equation is in the form of linear differential equation, the solution will be y into e power integral p dx is equal to integral q into e power integral p dx plus c. Here, the given equation. What is the given equation? dy by dx plus 2y is equal to e power x plus x. Here, p is equal to 2. This is py. And what is q here? the right hand side function of x e power x plus x and e power integral p dx, that is e power integral 2 dx, that is equal to e power 2x. Because it is a linear equation, the solution, therefore, the general solution is given by y into e power integral p dx is equal to integral q into e power integral p dx plus c. So I'll substitute everything. E power integral p dx, already we have calculated the value e power 2x. So I will write y into e power 2x is equal to integral q. What is q? Q is already, I have written here e power x plus x. E power x plus x into e power integral p dx means e power 2x dx plus c, or y into e power 2x is equal to integral first term e power 3x, second term x into e power 2x dx plus c. So I hope this is all clear. E power x into e power 2x, e power x into e power 2x, that is e power x plus 2x, that is e power 3x, e power m into e power n. Bases are equal, so powers can be added. The value is e power 3x. So first integration e power 3x dx first term, second term x into e power 2x dx plus integrating constant. So what is integral e power ax dx? The integration is e power ax by a. So here it is e power 3x by 3 plus, this is integral u dv form. So u is x, integration e power 2x by 2 minus u v1. v1 means the integration of this function. This is as it is, minus u dash into v2. v2 means the integration of e power 2x by 2, that is e power 2x by 4 plus c, that is y into e power 2x on the left hand side. Or what I can write, y is equal to, so I am writing e power 2x right hand side, this is e power x by 3 plus x into e power 0, that is x by 2 minus 1 by 4 plus c into e power minus 2x. And multiplying through the equation with e power minus 2x, you will get this solution. This is the solution of the given linear differential equation of first order in y. But you have to find here the particular solution, because there is a condition also, y of 0 is equal to 1. Given, what is the condition? When x is 0, y is equal to 1. So using this relation, we can find the constant also. So y1 means what? From this equation, you can see that 1 is equal to y1. E power 0, that is 1 by 3. X replace as 0 plus 0 by 2, 0 minus 1 by 4 plus c into e power 0, that is equal to c. X 0 means e power 0, that is 1. So c is equal to 1 minus 1 by 3 plus 1 by 4. So what you will get is 12 LCM, 12 minus 3 fourths plus 4 threes, that is 11 by 12. C is equal to 11 by 12. Therefore, what is the solution? Therefore, what is the final solution? On substituting C value, therefore, the required solution is y is equal to e power x by 3 plus x by 2 minus 1 by 4 plus c is 11 by 12 into e power minus 2x. That is the required solution. This will be the final solution of the given problem. Because c is 11 by 12, 12 minus 4 minus 8 plus 3, that is 8 plus 3 is 11 by 12. So replacing on c by 11 by 12, you will get the solution, which is the required solution of the given problem. So in this differential equation, we have to observe which model to be applied to the given problem. Based on the standard form, you can apply any model. if it is applicable to exact form, we can apply exact equation. If it is applicable to linear differential equation, you use that method. If the equation is a Bernoulli type, you follow the Bernoulli procedure. So based on the given equation, you reduce the problem to variable separable form or any other form and solve the equation to find the y value, right? So similarly, we do another problem. 1 minus x, solve the differential equation. This is also first order equation. If it is dy by dx means it is a first order equation. 1 minus x square dy by dx plus xy is equal to y cube into sine inverse x. So first write the given equation. The given equation is 1 minus x square dy by dx plus xy is equal to y cube into sine inverse x. This is a Bernoulli equation. This is a Bernoulli equation. That means if the function on the right hand side is not pure function of x, there is a y term also. We have to eliminate y first. So what we have to do is first divide throughout the equation by y cube into 1 minus x square. So because 1 minus x square also to be eliminated. It is dy by dx plus p into y is equal to, what is the general equation? Dy by dx plus py is equal to q into y power n. This is called Bernoulli equation. So in this method, to solve the Bernoulli equation, first we have to reduce it to the linear differential equation of first order. So by eliminating y power n and by using some substitution, we can reduce the equation to linear equation. So I am doing the same thing here. Divide throughout the equation by y cube into 1 minus x square. Then y cube 1 minus x square. 1 minus x square, 1 minus x square cancel. This is 1 by y cube into dy by dx. That is the first term. Second term, x by 1 minus x square into y by y cube. Second term. So divide with y cube into 1 minus x square. That I have done here. And here y cube will eliminated sine inverse x by 1 minus x square. So the total equation changes to y power minus 3 dy by dx plus x by 1 minus x square into y power minus 2. Y cancel. So it is y square. On writing in numerator y power minus 2 is equal to sine inverse x by 1 minus x square. Now, we assume y power minus 2 is equal to some other variable, u. Put y power minus 2 is equal to u. Then on differentiating with respect to x, minus 2 into y power minus 3 dy by dx is equal to du by dx. The formula n into x power n minus 1, minus 2 into y power minus 2 minus 1, that is minus 3. With respect to x on differentiating, you will get dy by dx also is equal to, on the right hand side it is du by dx. Or I can write y power minus 3 dy by dx is equal to minus 1 by 2 into du by dx. So call this is equation 1. Now y power minus 3 dy by dx is replaced by minus 1 by 2 into du by dx plus x by 1 minus x square into y power minus 2 is replaced by u. Right side, same thing, sine inverse x by 1 minus x square, right? So on now the equation, now 1 gives minus 1 by 2 du by dx plus, what is the second term? X by 1 minus x square into, this is u, y power minus 2 is u, is equal to sine inverse x by 1 minus x square. Now I am going to reduce the given equation into linear differential equation of first order in u. So now on multiplying by minus 2, we get du by dx minus 2x by 1 minus x square into u is equal to minus 2 sine inverse x by 1 minus x square. This is called equation number 2. So how we can write this equation? What this equation represents? A linear differential equation of first order in u. That is du by dx plus pu is equal to q. What is p here? Where p is equal to minus d2x by 1 minus x square and q is equal to minus 2 sine inverse x by 1 minus x square. And what is e power integral p dx? E power integral p dx is e power integral 2x by 1 minus x square dx. That is e power log 1 minus x square, because it is in the form of integral f dash x by f of x dx. The value is equal to log f of x, log modulus f of x. It is looking like minus 2x by 1 minus x square. So when you differentiate minus 1 by x square, the 1 minus x square, you will get minus 2x in the numerator. So this is log 1 minus x square, or this value is 1 minus x square. E power integral p dx is 1 minus x square. Now the solution is, u into e power integral p dx is equal to integral q into e power integral p dx dx plus c. What is u here? What is u? U is equal to, you can write u later, e power integral p dx is 1 minus x square. So u into 1 minus x square is equal to integral q. What is q? Q, I can see that minus 2 sine inverse x by 1 minus x square. Minus 2 sine inverse x by 1 minus x square. Minus 2 sine inverse x by 1 minus x square, and e power integral p dx value already we have calculated 1 minus x square plus c. And this gets cancelled, and u into 1 minus x square is equal to minus 2 into integral sine inverse x dx plus c. But what is integral sine inverse x? Integral sine inverse x dx. You have to calculate this. Already we have the formula. If you have a formula, you can remember that, or you can write, put sine inverse x is equal to t. Or what you can write, x is equal to sine t. Then dx is equal to cos t into dt. So what I can write, integral sine inverse x is t, dx is cos t dt. Integral t cos t dt. So what is the integration? T into sine t minus integral u v1 cos t integration t as it is. U dash means t derivative 1, sine t integration minus cos t, that is minus of minus. U v1 minus u dash into v2. v2 means sine t integration, that is minus cos t. Minus cos t, already minus is there, plus cos t. But what is the sine t? Sine t is equal to x, and t is equal to sine inverse x. So x into sine inverse x, first term, plus cos t. What is cos square t? 1 minus sine square t, that is 1 minus x square. So cos t means root of 1 minus x square. So this is the result of integral sine inverse x dx. So the solution will be u into 1 minus x square is equal to right side x sine inverse x plus root of 1 minus x square plus c. But what is u? You have assumed u is equal to y power minus 2. U is equal to y power minus 2 or 1 by y square. So I can replace it by 1 by y square. That is 1 minus x square by y square is equal to x sin inverse x plus root of 1 minus x square plus c is the required solution for the given Bernoulli equation. So here we have reduced the given Bernoulli equation into linear differential equation of first order in U, and then we write the solution by using the different formulas for integration, and after that we will get the required solution. So this is the third problem, and I would like to solve one more problem. I will give the idea, or I can solve this. It's very simple. The given equation can be written as, how I can write, y cos x plus sin y plus y of dx. So I'm writing this into this side, plus sin x plus x cos y plus x of dy is equal to 0. If you want to replace a dy by this term is plus this dx by this term, I can write, right? Solve the differential equation. This is equal to 0, like. So here, this is in the form, this is in the form m dx plus n dy is equal to 0. And I am going for the solution of an exact equation. Here what is m? Here m is y cos x plus sin y plus y. And n is equal to sin x plus x cos y plus x. Then what is dou m by dou y? The partial derivative of m with respect to y. When you are differentiating partially with respect to y, x treat as constant term. So the first term is cos x and sin y derivative cos y and y derivative y, 1. So cos x plus cos y plus 1. Similarly, calculate dou n by dou x. Already we have seen the method in regular classes. Just I am solving the questions in question bank. So you just recollect the formulas. It is an exact equation. I am going to search whether it is exact or not. Dou n by dou x, the partial derivative of n with respect to x, sin x derivative cos x, x cos y, partial derivative x1 cos y is factor remaining x1. That means what? Dou m by dou y and dou n by dou x both are same. This and this are same. That means what? The equation is exact equation. When the equation is exact equation, the general solution is integral m dx, treat y as constant term, plus integral the terms of n not containing x terms of dy is equal to c. That is the solution. So integral m dx means integral m means this is y cos x plus sin y plus y dx plus the terms of n not containing x terms. So in this all terms having x terms, so there is no such term, integral dy is equal to c. The terms of n not containing x terms. Here all terms having the x term, so there is no term which is not containing x term, so it is integral 0 dy. So what is the integration? On taking y constant, y into integral cos x sin x plus sin y integration, sin y with respect to dx, that is x sin y constant right outside, integral dx is x, and last one y into integral dx, x, that is equal to c. So which is the required solution of the given differential equation. So these are the problems which you can do by using the previous knowledge of the concept of differential equation of first order and first degree differential equations. So in the next class I will solve the same from same question bank, from same part, I'll solve the remaining 4 problems. So, and this question bank of the course, Differential Equation Vector Calculus BT23, published by IARE. And these question bank will be useful in preparing the examinations like mid exams or final examinations, because it covers all models of the problems in the textbook or in our course syllabus. So this is a practice problem, practice session. So this will be more useful for you, because you can recall all the problems, and you can solve by recalling the problems. You can solve by considering all the models and solutions, and this will be very useful for the student in the final stage of completion of the course. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.